Alright, so let's take a look at this multi-loop circuit with three resistors that I wouldn't really say are in series or parallel. Series resistors always have the same current through them. And these three currents look different because of that junction right there. And parallel is the same current that splits up and goes across either resistors, well, either one resistor or another, and doesn't share any of the same charges going across them. But in this problem, some of these will share charges. Some of the ones that might flow here might go into here, and others might go into here, but maybe some of the ones that might be flowing here go into here. This isn't series or parallel, it is just multi-loop. But we have rules to be able to solve these. It involves looking at the current and the loops. First thing about the current, I'm going to say that this current going right here is I1. And I'm going to say it's going to the right. I feel pretty confident about that because we've got a negative terminal of battery here, positive terminal. And this 28 volt battery is so much more powerful than any of the others. This current's going to get pushed in here and travel this way. I feel good about calling this right here I2. And saying it's going to go down and travel back towards that negative end of that terminal. And then this current here, I'm definitely going to call it I3, but I don't totally know whether that's going to be to the right or to the left. At first, I could see arguments for both sides. I could say, hey, look at this 8 volt battery. That's the positive end. That's the negative end, and it's much bigger than this 1 volt battery right here. Maybe the current's going to go that way. But some people say, well, maybe the 28 volt battery is so much stronger that it's going to push the current backwards through that 8 volt battery and go this way. I don't know. I'm going to guess and say that the current's going this way, and I'm going to call it I3. It's important to know that that's just a guess. It doesn't really matter, though. If I'm wrong, I'll just end up with a negative number, and it turns out the current is going to the right. But what I have to do is be consistent in all my loops. I always have to set that direction to state that this, I'm assuming this is the higher potential, this is the lower potential, to make sure that everything works out. So, now to look at some of those loops. Here, let's look at this first loop, which I'll draw right here. And I'll say that this is plus 28 minus, because we are going in the regular direction, downstream, down that current, higher potential to lower potential, where that flow of positive charge is going, minus 4I1 minus 2I2 equals 0. That is 100% true, totally the case, has to be true. That is Kirchhoff's voltage law. But the problem is, I can't solve it. It's got an I1 and an I2. I need more information. Some of that more information, one of that can come from this loop that I'm going to write in green right here. Now this one has some interesting things. We'll talk about that 1 volt battery going the other way in just a moment. But I'm starting my loop right here. I always like to start it right before the biggest battery. And this is going to go plus 8 minus, it's 1 times I3, because that is a voltage drop. Delta V equals I times R. But I'm just going to say minus I3, but really preface that that is multiplied by 1, because that's a resistance. Minus 2I2 equals 0. True. That is... Oh, well, that was that. Oh my goodness. Not true. Thank you to all the people that are screaming at their screens right now. I forgot about this 1 volt battery. Then we're going against it. That's going to be minus I... Minus, not I, 1. Ugh, I's and 1s. They look so similar. Minus 1 equals 0. So let me really clear that up. And we'll talk about it. This one is a battery going the other way. So this is actually going to cause a voltage drop. This is the higher potential. This is the lower potential. So that is -1 right there to make this loop. And this is a totally true statement, just like the one before it. However, I can't solve these because this has an I3 in it, and this is two equations with three unknowns. I need another statement. But don't worry, I've got this one. I1 plus I3 equals I2. That's how I defined it right here. Watch the directions. This going into this junction, this going into this junction, this going right here has to be I2. And now I've done something awesome. I have made three equations with three unknowns. I want you right now, pause the video or answer the Edpuzzle question and say, all right, what is the solution to this system of equations with this three things? Take a moment and make that happen. And what you're going to find out is, what you have now found out, is that I1 is equal to 5 amps. I2 is equal to 4 amps. It turns out the current is flowing right through here this way. And then I3, you solved in that system of equations, you saw that it was equal to -1 amps. And that means something, that our current is actually going the other way. If I redraw this, 1 ohm. You know what? I'm just going to be smart right here. Let's just call it a 7-volt battery with a 1 and an 8 fighting each other. And this 28 volts. Here's what this one looks like. It's really got 1 amp of current going this way, 4 amps of current going this way, and 5 amps of current going that way, which makes a ton of sense because I see 5 flowing in, 4 turns the corner to go this way, 1 turns the corner to go this way. That's the path of least resistance for these charges right here. They'd rather go like upstream on this battery, like they really want to get to the negative end of that terminal right there and away from the positive terminal of that very strong battery. There's one way I can always check my work from what I did before. Not only should it make sense of the current law, but I have an independent equation I haven't used. I haven't looked at this outer loop right now to see if this makes sense. If this makes sense, this current law should work, where I'll start, I went this direction, so I'm just going to start right here. I'm going to say +7. Going up this battery, and then this is the lower potential, this is the higher potential. This is going to be +1. 1 volt right there, 1 amp times 1 ohm, and it's a plus, even though it's a resistor, because I'm going upstream. This is the lower potential, this is the higher potential, the way the current's going. That's an energy drop as this goes through here, but that is +1 across that. And then that is +20 as I keep going through here, because that's 5 amps going this way, and I'd go 20 volts upstream. 4 times 5 is 20, lower potential, higher potential. That's the way the current's actually going. +20, and then right here, this go in the opposite direction of this battery. This should be -28 should equal 0, and lo and behold, 28 minus 28 is 0. So that all checks out, and I did this problem correctly. That's how you handle these multi-loop circuits and setting up your system of equations.